Modern industrial automation faces a structural fragmentation. Cognitive AI models, physical robotics, and decentralized financial ledgers currently operate in technical silos. Many developers currently navigate this by vibe coding, a practice of utilizing ad hoc natural language prompts without formal verification mechanisms to audit the AI's output. When autonomous systems manage physical hardware and financial capital, these ad hoc methods fail. These environments require agentic engineering, a discipline of strict constraints, deterministic testing, and continuous feedback loops. A functional machine economy requires a zero-trust orchestrator that translates non-deterministic AI reasoning into the deterministic commands required for machine joints and cryptographic ledgers. The Denarii Machine Economy Research Laboratory serves as a physical and architectural testbed built specifically to solve this orchestration requirement. The cognitive core of this system is the Denarii Agency Framework. The agency replaces monolithic AI models with a coordinated board of specialized AI executives. Within this board, personas hold distinct authority. The reality checker evaluates empirical evidence, requiring mathematical verification of hardware attestations and state invariants before a physical action is authorized. We can observe how this logic scales by building the Denarii Orchestrator layer by layer, moving from cognitive reasoning down to physical robotics. As we transition towards systems driven by high-level human intent, the Denarii architecture provides the hardware-enforced constraints necessary to contain and verify that intent. At the operational layer, the Denarii agency utilizes a declarative registry of 232 specialized agent personas. The system operates via an active board of 12 TEE-hardened executives, rather than attempting to run the entire registry simultaneously. This executive board begins with the starter squad, a group of personas covering generic engineering roles like backend and security architecture. For decentralized finance, these roles transition into specialized personas. The backend architect serves as the liquidity path architect, while the security architect functions as the enclave guardian sentinel. Running multiple complex AI personas inside secure hardware partitions creates significant memory pressure. The static prompt memory overhead for these personas can consume the available secure memory before the execution sequence begins. The dashboard reveals the solution, the Hermes Lazy Router. It dynamically isolates and loads only the specific subset of agents required for the active transaction. Scaling cognitive reasoning depends on strict memory orchestration and the physics of hardware resource limits as much as it does on model intelligence. This creates a security requirement. If an AI governs physical robots and financial capital, standard cloud execution environments lack the necessary isolation. Standard hypervisors and host operating systems remain vulnerable to prompt injections and unauthorized state manipulation. The hardware solution lies in trusted execution environments. Technologies like Intel TDX and AMD SEV SNP create physically isolated partitions directly on the silicon. Intel TDX uses AES-256 cipher encryption on the virtual machine's memory space, removing the host OS from the trusted computing base. This protection is limited by the enclave page cache, which is a restricted region of physical memory. If the memory footprint exceeds this boundary, the system pages memory in and out of the enclave, introducing latency that disrupts real-time tasks. The lazy router manages this by limiting the active memory footprint to only the actively routed agents, minimizing prompt memory overhead. It manages this efficiency through 4 core tools: search, inspect, load, and delegate. By operating within these hardware limits, the AI's API keys and reasoning remain tamper-proof. Within the machine economy, security protocols must be designed to avoid the execution latency that would otherwise stall real-time physical coordination. To act, the secure, enclaved AI model must transmit physical commands to a real-world actuator. The Denarii lab utilizes an open standard for this communication, the Model Context Protocol, or MCP. It uses the JSON RPC 2.0 transport protocol to decouple the AI's isolated host environment from the systems executing physical tools. During the discovery phase, the AI queries the MCP client. The client reveals the available tools and their specific schemas to the model in plain text. An AI can query machine status via an industrial SCADA platform or adjust a motor set point through these standardized function calls while remaining inside its secure sandbox.
Standardized translation layers allow non-deterministic thought to trigger deterministic physical action safely. Mathematical simulations are insufficient. The orchestrator's validity requires physical embodiment. The laboratory deploys a tiered physical validation pipeline utilizing a fleet of advanced bipedal humanoid robots. Tier 1 utilizes the Unitree G1 EDU. It serves as a high-volume platform for testing collaborative algorithms and fine-grained manipulation. Tier 2 utilizes the Agility Digit, featuring a reverse-jointed leg design optimized for continuous warehouse logistics and autonomous sorting. Tier 3 scales to the Figure 02, testing precise industrial assembly using highly dexterous hands and vision language action models. Tier 4 employs the electric Boston Dynamics Atlas for heavy industrial manipulation, validating closed-loop labor procurement and autonomous battery swapping. This humanoid fleet is supported by mobile robots like the Turtlebot 4 and Husky UGV, which manage high-density micro-logistics routing. Generalized physical agency is the ultimate test for any multi-agent architecture. We can now map a complete transaction by unifying the three pillars of the Denarii Orchestrator: cognitive, execution, and settlement. Consider an autonomous vending machine that identifies an inventory threshold has been met. The local AI agent initiates an autonomous procurement bid to acquire a replacement item from the warehouse. The transaction is instantly executed on-chain via a Flare smart account once terms are finalized. The reality checker agent confirms the cryptographic hardware attestation before any physical movement is permitted. With the state proven, the orchestrator authorizes physical action. An Agility Digit robot retrieves the item from the warehouse, completing the machine-to-machine exchange. Sustaining this closed-loop testing requires an extensive physical and digital footprint. The procurement matrix includes dual RTX 5090 workstations for local inference, dedicated XRPL and Hedera mirror nodes, and industrial IoT arrays. This infrastructure functions as an operating system for fully autonomous enterprises. The Denarii infrastructure demonstrates that the next economic era, the autonomous machine economy, will be defined by verified execution.